Hi guys, today is May 15th and we are going to be learning Chapter 11-5 Rotations. Let's get started. A rotation is a transformation in which a figure is turned around a fixed point. Notice my original triangle, and I'm going to show you this is my original shape. It is rotated around the coordinate plane. It starts in quadrant 1 right here, right? And then as you can see, it rotates 90 degrees, ends up in quadrant 4. Then it's going to rotate another 90 degrees, or total of 180 degrees. And then another 90 degrees, or total of 270 degrees clockwise, right? And then finally, when it rotates 360 degrees about the origin, right, it will end up looking the same and will become the original shape. So in the table below, you will see that if I rotate a shape clockwise 90 degrees, if I went the other way counterclockwise, it will be 270 degrees. 180 degree rotation is the same if you go counterclockwise or clockwise. And then if you go clockwise 270 degrees, right, you would end up in quadrant 2. Then counterclockwise, you only need to rotate that shape, right, only 90 degrees, only 90 degrees. So that will help us when we are working on rotating a shape using the rules. Before we jump to that, I'm going to ask you to let's talk about rotational symmetry. So some shapes have rotational symmetry, some shapes don't. The rotational symmetry happens is when the object is rotated, right, or turned around or about a center point a number of degrees, and the object appears the same after that rotation, right? It will look exactly the same. Now the figure has rotational symmetry if it's congruent or the same, looks the same as the original shapes after a rotation of 180 degrees or less. It has to be greater than 0, but it has to be less than 180. Usually it's less than 300 degrees for some of them, but let me tell you, majority of times it's 180 degrees or less. So let's take a look at the first example. I'm going to ask us to find the angle of rotation, meaning how many degrees do I need to rotate the shape so it will look the same, right? It will appear as an original image. So the first thing we're going to do is we're going to find order of rotation. And order of rotation is how many times do I need to turn the shape around the entire 360 degrees, right, for the shape to look identical or as original image. So if I take a look at this snowflake, if I turn it once, right, I don't know how many degrees yet, but I know if I turn it once, it will look identical to the original shape. And twice, 3 times, 4 times, 5 times, and 6 times. Okay, so I'm noticing 6 times is our order of rotation. I can turn the shape 6 times and it will look the same. So now we're going to find angle of rotation. And I know that the shape rotates 360 degrees, right? It's a circle. So, and I also know that the order of rotation is 6. So if you take 360 degrees, right, and divide it by 6, you will get the angle of rotation. And that would be 60 degrees. So ladies and gentlemen, every time you rotate the shape 60 degrees, the shape will look the same, and you can do it 6 times in this particular snowflake. So the snowflake has the rotational symmetry. In our next example, ask yourself, does this object have rotational symmetry? Pause me, figure this out, and let's compare our answers. So I can see that I actually can turn this object 3 times, right, for it to look the same. 1, 2, and 3. And I just need to find out, so order of rotation is 3. And then angle of rotation, I'm abbreviating, is 360 divided by 3, and that would be 120 degrees. So ladies and gentlemen, 120 degrees, I need to rotate it 120 degrees for the object to look the same. I also drew some examples for you of the objects that don't have rotational symmetry. Notice this heart. You have to rotate it 360 degrees for it to become its original image, right? So there's no rotational symmetry here. Also, this little house here, you have to rotate it 360 degrees. Remember, rotational symmetry, it has to be less than 360 degrees, and usually it's 180. So this one also does not have rotational symmetry. Okay, moving on to rotating the figure about or around the origin. I'm going to teach you the rules, but before that, if you would like to learn how to do that, how to rotate a shape using patty paper, so it's called a patty paper, or it's called a wax paper, or it's called, you will notice if you have moms or sisters, or you and you bake, you know you will have a parchment paper, so it's called parchment. And you can use that to help you rotate. Please watch a video on how to do that. It's a good video, so it will help you if you're confused about the rules. You can always, or you want to check your work, you can use parchment paper to rotate a shape. So ladies and gentlemen, we're going to apply these rules when we rotate a shape counterclockwise, again, I don't need this part right here, around or about the origin, okay? Counterclockwise, about the origin. Now, if you are rotating a shape clockwise, then if you're rotating it 270 degrees clockwise, you're going to use these rules at the top. And then if you're rotating it 90 degrees clockwise, you're going to use these rules. So again, I'm talking about counterclockwise, but here's additional, you can swap top and bottom, and then when you're rotating a shape clockwise. So in this example, we have a wonderful triangle ABC, and I already started. Again, it's going to be my original shape, and I'm going to rotate it, okay? I'm going to rotate it 90 degrees clockwise around the origin. So if you're using parchment paper, you're going to put your pencil right here, and you're going to hold that pencil and then move the parchment paper around 90 degrees, right? You should end up in quadrant number 4. So let me label this first. We have A, we have B, and we have C. This is my original shape, and I'm going to rotate it 90 degree clockwise. So that means 90 degree clockwise is the same as 270 degrees counterclockwise. So the rule is we're going to swap X and Y. We're going to swap the order of that and change the sign of the new Y value. Okay, what is she talking about? We're going to change the new Y to the opposite sign. So if it was positive, it becomes negative. If it's negative, it becomes positive. Let's quickly draw, actually write down our new coordinates. A prime, again, we're going to swap X and Y, so 2 and 3, right? 2 and 3, and then change the value or the sign of the new Y. So it's going to be -3. B prime is going to be 4 and 6, and we're going to change 6 to -6. And C is going to be 6 and 3, and we're going to change the sign of the new Y. Let's see if we did a good job. I'm going to use blue for my new shape. So 2, -3. That's my A prime. B prime is going to be 4, -6. That's a B prime. And C prime, I forgot prime, is going to be 6, -3 right here, C prime. Let's draw this. 1, 2, 3. I don't like that. Okay, we're going to keep this shape. Okay. So that's my, take a look at vertex A. You can You can tell right away, right, that it's moved. And the same thing, the B moved and the C. Notice we ended up in quadrant 4, so we did a good job, right? Moving on to the next rotation, I would like to talk to you about rotation 270 degrees clockwise, ladies and gentlemen. That means counterclockwise is going to be 90-degree counterclockwise rule. I'm going to use green for that. So if I'm rotating 90 degrees counterclockwise, or 270 degrees, here we go, 270 degrees clockwise, right? I should end up right here in quadrant 2. So let's see if it works out. So A prime prime, the rule is, and I'm going to show you the rule, 90 degrees counterclockwise. We're going to swap the values and change the value or the sign of new x value. So let's take a look. A prime prime, we're going to swap 2 and 3 and change 2 to -2. B prime is going to be 4, 6, and it's going to be -4, 6, and C prime is going to be 6, 3, and it's going to be -6, 3. Let's see if I did a good job. -2, 3 is going to be right here. That's our, I'm going to lower it a little bit so I can write better. A prime prime, B prime prime, -4, 6, -4 and 6. It's going to be my B prime prime. And C prime prime, -6, 3, -6 and +3. Take a look at this, guys. My shape, I don't like that. I'm going to keep this one. Okay, so this is my C prime prime. So notice again my vertex, look at that, it rotated. Do you see that? That's so cool. So finally, I'm going to show you really quickly 180 degree rotation. Now notice we don't have to swap the coordinates, but what we have to do is we have to change the signs of both x and y to the opposite. So I'm going to use black, and I'm going to do A prime prime prime. It's going to be 2, oops, sorry about that. We're not swapping anything. 3, 2, and it's going to be -. B prime 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 is going to be 6, 4. We're not swapping anything. -, and C prime 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 is going to be 3, 6, and negative for that. Really quickly, again, 180 degrees from my original shape. We should end up in quadrant 3 when I rotate 180 degrees. So that's going to be -3, -2, -6, -4, and -3, -6. Notice that. 1, 2, 3. And that's going to be A, B, C, prime, prime, prime. Here we go. We did it, guys. So I'm sorry I went so fast. On Monday, I will post a little video on how to rotate a shape about a point. But yet again, you can use a parchment paper to help you. But if you like rules, and I do, and like me, so you can use that. But again, parchment paper always works. And majority of our rotations are going to be around the origin, you guys, around the origin. So again, please watch all the videos. Thank you for participating in distance learning. I miss you, and I will talk to you next time. And signing out, Mrs. Boone here.